Show you now how to find the exact value of that third side length on a right angle triangle. The way we do this we call the Pythagorean theorem. The Pythagorean theorem tells us that a squared plus b squared is equal to c squared, where a, b, and c are the three side lengths here on a right angle triangle. If you have a close look, notice that C is the longest side. There's a fancy name for that. We call it the hypotenuse. It's another a Greek name for the longest side of the right angle triangle. Now keep in mind this only works if you have a right angle triangle. There's a way of modifying it to work for all triangles. We call that the cosine law, but you'll learn that much later. So let me show you how this works with a practical example here. So if I have a triangle and my side lengths are 3 and 4 and I'm looking for the long side, I identify the Pythagorean theorem, which is that a squared plus b squared is equal to c squared. Now, this is side length A and this is side length B. So a squared is 3 squared. And b squared is 4 squared. So I have 3 squared plus 4 squared, and that's equal to c squared. Three squared plus 4 squared is c squared. Now, 3 squared is 9. And if you've forgotten that, I've got a times table right here for you. See, 3 multiplied by 3 is equal to 9. And 4 squared, 4 times 4, can you see it? Line up the 4 and the 4. 4 times 4 is 16. So I have 9 plus 16. And when I add those together, that gives me c squared. 16 plus 9 is 25. So c squared is 25. That means some number when multiplied by itself gives you 25, and that's the value for c. Now let's look over at, here we go. Let's look over at our multiplication table. Now, try and find 25 somewhere inside the grid. And look across the top row and the far left. Can you see two numbers that multiply together to give you 25 that are the same number? Look closely. It's 5. 5 times 5 is 25. So this is a bit of a tricky step here. It's kind of like we're not looking for the answer, we're looking for the question. 5 times 5 is 25. If c squared is 25, then c must be equal to 5. Because if c squared is 25 and 5 squared is 25, c must be equal to 5. So our answer for this triangle is that c is 5. Because 3 squared plus 4 squared is equal to 5 squared. Now that one worked out really nicely. Most of them, however, are not going to work out as cleanly. Look at the second example. Now I've got 5 as one of the sides and 9 as the other side. That does not mean that 5 plus 9 is equal to c, but what that means is 5 squared plus 9 squared is equal to c squared. What is 5 squared? Let's look at the table. 5 squared is 5 times 5. 5 times 5 is 25. Plus 9 squared. What's 9 squared? 9 squared is 9 times 9. Let's have a look. Can you see 9 times 9? Remember, the answers are always for these squared numbers. the answers are always going to be along this diagonal that I'm circling here. 9 squared is 9 times 9, and then just follow it up. 9 times 9 is 81. Okay, so 5 squared plus 9 squared is equal to 25 plus 81. All of that's equal to c squared. What's 25 plus 81? That's 106. 106. Now that's not the side length, it's the square of the side length. C squared is 106. Now, what does that make C? Without a calculator or maybe applying Newton's method, I can't tell you exactly, but we can get close. Let's look at our times table again. Remember, we're looking for the square to be 106. If you look at your times table, notice that 10 squared is 100 and 11 squared is 121. C can't be 10 because 10 squared is 100, not 106. But it also can't be 11 because 11 squared is 121. It's too much. That means that C is somewhere in between 10 and 11. It's going to be like 10.3 or 10.4, something like that. I can't figure that out exactly in my head. I can only guess. But what we can say is that C is between 10 and 11. So it's maybe about 10.5, not exactly, but somewhere around there. If you want to know the exact value, all you've got to do is find the square root of 106. But for now, we say C is between 10 and 11. And another way to write that is I could write the letter C and say it is less than 11, and at the same time, it's greater than 10. And so for now, that's going to be my answer. So my answer is, what is C? C is somewhere between 10 and 11. Okay, let's try another example. Okay, take a close look at this example. It's similar to questions we've done, however, there's something different about it. Can you spot the difference? I'll tell you. In the other two questions, we were looking for the hypotenuse. We were looking for the longest side. In this question, we know the longest side and we're looking for a shorter side. So that changes things a little bit. When we write a squared plus b squared is equal to c squared, the a value is 5, so 5 squared plus our unknown b squared is equal to 10 squared. So this is starting to look a bit tricky. What's 5 squared? 5 squared is 25. So 25 plus b squared is equal to 10 squared. You know what 10 squared is? You probably know, but I'll go over to the times table to help you figure it out here. 10 squared. So what's 10 times 10? Can you see it? 10 times 10 is 100. So 25 plus b squared is equal to 100. Okay, starting to look very tricky. Now, what would you have to add to 25 to get 100? Let's say at 25 cents, how many more cents would you need to have 100 cents? Can you guess? You would need 75. So that means that this b squared is actually worth 75. Or let me write it out here. B squared equals 75 because 25 plus 75 will give us 100. So if b squared is equal to 75, let's look at our times table. Try and figure this out. What number times itself will give us 75? What's 8 times 8? 8 times 8 is 64, so 8's not enough. What's 9 times 9? 9 times 9 is 81, and that's too much. So that means b squared is in between 8 and 9, because 75 is in between 8 squared and 9 squared. So it's between 8 and 9. So again, all I can write for now is that b is between 8 and 9. So it's less than 9, and it's greater than 8. Now, how do we precisely find it? We can precisely find it this way. There's a button on your calculator called the square root button. If b squared is 75, then b is the square root of 75. Well, technically it's plus or minus root 75, but don't worry about that right now. Let me get my calculator up. And I want the square root of 75. All right, so for some reason it can't open my calculator, so I'll use Google. Find the square root of 75. And that's going to give me 8.66. So that means that b is equal to 8.66. See how that's a number between 8 and 9? And the same thing will work for all of these. We can go back and find the answer for all of these. So up here, remember c squared was 106, so we said c was between 10 and 11. We can find the exact value by finding the square root of 106. So c is precisely equal to the square root of 106, and the square root of 106 is 10.2956. We could round that to 10.3. So C is 10.3. And what did we say before? Before we said it was between 10 and 11. Okay, so to recap, let me tell you. The Pythagorean theorem tells us that side length a squared, and if you want a picture of that, we're not saying the side lengths are equal to each other. What we're saying is the squares of the side lengths are equal to each other. So what that really means is the area of this square, that's a squared, plus the area of this squared, that's b squared, is equal to the area of this squared, that is c squared. A squared plus b squared is equal to c squared. And we can use that to find any missing side length if we know the other two, as long as we have a right angle triangle. We write down a squared plus b squared equals c squared. And then we put in the values for a, b, and c. And then we do a little bit of math and try and figure out what either a, b, or c are. Remember, the first thing you do is you square them, then you add or subtract. That's going to give you a big number. Then you want to look at your table and work your way backwards. Or you can use the square root button on your calculator to find the exact value of the side length.